All right, so we're on day 3 and the final day of our Semex1 study guide. And we got 26 through 40 today, which is actually 30 through 45 overall. So number 26, you're told QRS is congruent to TUV. That QS is 4x plus 5, 4V plus 5, and that TV is equal to 6V minus 9. And you need to find the length of each, okay? So we got QS, first and last letter in the description, and we got TV, first and last letter in the description. They're congruent to each other. So we're going to set an equation with 4V plus 5 equal to 6V minus 9. Going to subtract 4V. So 5 equals 2V minus 9. And then we're going to add 9. 14 equals 2V, and then divide by 2. So 7 equals V. So if 7 equals V, we're going to go back to these expressions and we're going to substitute. So we get 4 times 7 plus 5, and that's 33. And then we get 6 times 7 minus 9, and that's 42 minus 9, which is 33. So there's your two pieces. Number 27, ABC congruent to PQR. B, angle B is equal to 2V plus 6. Angle Q equal to 8V minus 6. And you need to find the measure of each angle. So B is in the middle, Q is in the middle, they're congruent to each other, so the 2V plus 6 is equal to the 8V minus 6. Subtract 2V from each side. So 6 will equal 6V minus 6. Add 6. So 12 equals 6V, and then divide by 6. So 2 equals V. Same concept, we're going to go back and substitute. 2 times 2 plus 6. That gives me a 10. And 8 times 2 is 16 minus 6 gives me a 10. So there's your two angle measures. 28. You got a triangle. With a 34-degree angle. Left side's 21, right side's 21. And we've got an angle that's X degrees. And you're asked to find the value of X. All right, so this is an isosceles triangle. You got two congruent sides. If the two sides are congruent, then the angles opposite those sides are also congruent. So we add an X to this right-hand side. So we got x plus 34 that equals 180. So our 2x plus 34 equals 180. Subtract 34. 2x equals 146, and then divide by 2. $73. Similar concept for number 29. You've got another isosceles triangle. Now your x is at this vertex angle, and you're told the two sides are congruent. You get a 76. So if the two sides are congruent, again, the angles opposite those sides are also congruent. That angle is congruent to that angle. So we write in a 76 right here. And again, the three angles need to sum 180. So we get x plus 2 of the 76's, 152, equals 180. Subtract 152 from each side. X equals 180 minus 152, which is 28 degrees. All right, number 30. We got triangle RST, point U. We're told that RS is congruent to ST. RS is congruent to ST. That angle RST, that would be this vertex angle up top, is 6x minus 44. Angle STU is 7x. So 7x right here. And you need to find the value of x. All right, so what we've got here is an interesting situation. We've got an exterior angle that's equal to the sum of its two remote interior angles, but we don't know what angle R is. And then we've got two angles here, the 7x and the angle to the left of it, that form a straight line. Those two could be a linear pair. What we have to do in this problem is add variables that aren't x's, because these base angles in this isosceles triangle don't really have a direct relationship with the vertex angle and the exterior angle. So we're going to call these y. Now keep in mind we're solving for x, so throughout this process we're going to keep everything in terms of x. So we're going to write our first equation that deals with this linear pair. And we're going to say that 7x plus y is equal to 180. And then we've got another equation that we're going to write, and it's going to focus on the interior angles. So we've got a 6x minus 44 plus these two y's. That sum has to be 180 as well. So now we've got two variables in two equations. The simplest way to solve this problem, since we're solving for x, is to go to this equation, subtract 7x from each side. We get y equals 180 minus 7x. Since we know what y equals, we go to the other equation, and where there's a y, we substitute 180 minus 7x. So we do 6x minus 44 plus 2. And where the y is, we write 180 minus 7x. And all of that on the left still has to equal 180. So now we're going to clean this whole thing up. We've got a 6x minus 44 plus, we're going to do the distributive property. 2 times 180 is 360. And 2 times negative 7x is negative 14x. Still equal to 180. Now we're going to combine like terms. I got a 6x minus a 14x. That gives me a negative 8x. And I got a negative 44 plus 360. That gives me positive 316. And it's still equal to 180. But now we only got a couple of steps left. So we're going to subtract 316 from each side. Our negative 8x is equal to 180 minus 316 is negative 136. Gonna divide both sides by negative 8. And our x equals 17. Number 31. The legs of an isosceles triangle. So isosceles triangle has two congruent sides. The congruent sides are the legs. They have lengths of 3x plus 3 and x plus 9. The base has a length of 3x minus 1. What is the length of the base? So we need the length of this right here. 3x minus 1. Okay, so the two sides, the legs are congruent. So 3x plus 3 is equal to x plus 9. Gonna subtract 3 from each side and subtract x from each side. So what I get is 2x is equal to 6. Divide each side by 2. And x equals 3. So if we know what x equals, we go back to the expression for the base and we substitute. So we do 3 times 3 minus 1. So 9 minus 1 equals 8. So there's the length of the base. Number 32. In number 32, what we've got, a side that's 20, a mid segment that's 2x minus 4. Now we know it's a mid segment because this point is in the middle of this top side. That's what the tick marks tell us. And we know this is a midpoint because it's in the middle of this bottom side, noted by the tick marks. So the mid segment of a triangle is half the length of its parallel side. So what we say, or the equation that we write, is 1/2 of 20 equals 2x minus 4. Half of this side right here half this blue side is equal to this purple side. So half of 20 is 10. Add 4 to each side. 14 equals 2x, and divide by 2. So 7 is equal to x. Problem number 33, instead of tick marks, you have actual segment lengths, but you have the same concept. In problem number 33, we've got two ways to write this, okay? This mid-segment, 6x plus 5, 2x plus 90. If we had to deal with the half portion that we just did in the previous problem, we would have decimals, and I know I don't like decimals. The other way that we can write this is that this mid-segment, if it's half of its third side, well then the mid-segment times 2 equals the third side. So that's the second way we can write an equation that deals with mid-segment. So we can say that 2 times 6x plus 5 is equal to 2x plus 90. So the distributive property on the left, we get 12x plus 10 equals 2x plus 90. I'm going to subtract 2x from each side. So 10x plus 10 equals 90. Subtract 10. My 10x equals 80. And then divide by 10. So I get an x that's equal to 8. The question was to find the length of the mid-segment. So the mid-segment is going to be equal to 6 times 8 plus 5. And 6 times 8 is 48, plus 5 is 53. In problem 34, it's another mid-segment problem, except you got a building and a tree. Here's your building, and then you've got tick marks, and then you got this tree. I'm going to draw a different tree. I like my tree better. They're asking you for the height of the tree. Well, the top of the tree is in the middle of this top side. The base of the tree is in the middle of this bottom side. You're told that the building is 120 feet tall. So the tree's half the height of the building. So the tree is equal to 120 divided by 2. So it's 60 feet tall. And that moves us to the last page of the study guide, number 35. DF bisects EDG. So we got E, D, and G. F is out here. F bisects it. So if F bisects it, these two angles are congruent. Now we've got this segment and this segment. If a point is on an angle bisector, it's the same distance from the sides of the angle. We're told that FE is 7x plus 12. And we're told that FG is 10x. Find the value of x. Well, 7x plus 12 is equal to 10x. Subtract 7x from each side. 12 equals 3x. Divide both sides by 3. And 4 equals x. In problem number 36, we've got same concept. We've got an angle and we've got an angle bisector. We got angle TSR, point Q, that's on the angle bisector. Now look, if they tell you that Q to R is the same as Q to T, which they do, that means that 4x plus 6 is equal to 6x minus 2. Remember, if a point is equal distance from the sides of an angle, then it's on the angle bisector, and these two are congruent. So what they're asking for now, be careful on this problem. Find the measure of RST. RST, look, that is the whole angle, guys. This problem gets missed a lot because people don't find the entire angle measure. They either solve for x and answer that, or they solve for x and substitute it once and choose that as an answer. We got to solve for x first. So I'm going to subtract 4x from each side, and I'm going to add 2 to each side. So on the left-hand side, I get an 8, and on the right-hand side, I get a 2x. And then I can divide by 2. So 4 equals x. Now, since these two angles are equal to each other, this angle is equal to 6 times 4 minus 2. 6 times 4 is 24, minus 2 is 22. Well, if this angle is 22 degrees, then this angle is 22 degrees. So the measure of angle RST is equal to 22 times 2, which is 44 degrees. All right, 4 to go. For these 4 problems, what you need to know is that the sum of the interior angles equals n minus 2 times 180, where n is the number of sides. So number 37 asks, what is the sum of the angle measure of a 30-four-gon? You take 34 minus 2 times 180. $12,240. Now, in problem number 38, it says the sum of the angle measures of a polygon with S sides is 3420. So now they're telling you what the sum is. So I'm going to use S instead of N because they're using S in the problem. And we're going to say S minus 2 times 180 equals 3420. Going to divide both sides by 180. So our S minus 2 is equal to 19. So add 2 to each side. And our S, or our number of sides, is equal to 21. Number 39 asks you, what is the measure of one angle in a regular 20-gon? One angle in a regular 20-gon. Well, that's going to be the sum of the angles divided by 20. Okay? The sum of the angles divided by 20. So the first thing we do is we can take what is the measure of one angle? So we're going to go 20 minus 2 times 180. And we're going to divide it by the number of sides, which is 20. Or, I'm sorry, the number of angles. The number of angles is the same as the number of sides. So in the numerator, we get 18 times 180, which is 3240. And we divide it by 20. 162. And if you want to make a note, you can say sum of angles divided by number of angles. And number 40 asks you, the sum of the measures of two exterior angles of a triangle is 259. What is the measure of the third exterior angle? Exterior angles. Always. Sum 360. Doesn't matter what the shape is. All right. The sum of the exterior angles, one at each vertex, is 360. So the question tells you that two of the exterior angles of a triangle is 259. Well, a triangle has 3 sides and 3 angles, so a triangle has 3 exterior angles. So if you take 360 and you subtract what 2 of them are equal to, which is 259, it gives you the third angle. So 360 minus 259 is 101 degrees. And that concludes our study guide, your study guide for semester 1 exam.